Okay, so this video is going to serve as the second uh, video for Geometry's Unit 3 Day 4. In it, we're going to talk about like a lot more in depth about how to solve trigonometric equations, namely those that are going to have multiple solutions, right? So I've got 6 examples here. I'm going to work through them just at lightning speed. Um, I'm going to try to make all of these as visual as I can. So hopefully this video doesn't take too long. I want to keep it beneath 10 minutes if possible. I'd like to keep it beneath 5, but that never ends up being possible. Okay, so the objective is always the same with these. We've already seen these before. We always want to get the trig function by itself first. Then we look to calculate what theta, the unknown angle, is, right? So first, to get the tangent theta by itself, we're obviously going to want to divide by 15 first, right? So then we're going to end up with tangent theta is equal to negative 5 square root of 3 over 15. And I'm going to go ahead and reduce because that just bothers me. We end up with negative square root of 3 over 3. Okay, so now we see we have the tangent function by itself. We're going to undo that, of course, with arctangent. So we're going to do arctangent, right? So that and that are going to cancel. So now I've just got theta by itself on the left side of the equation, but I also need to do arctangent to this side as well because, golden rule of algebra, what you do to one side, you do to the other. Okay, so you can refer to a calculator for this, or, you can be like me and just have these memorized, whatever. So this is a special trig ratio. I know it's going to involve the reference angle of 30. Right? So in the previous video, we talked about reference angles. So you're going to see why this is important. Now, again, your calculator is not smart enough to do this. Oh, good Lord. Let me try to draw this better. Okay, and every time you solve one of these, or are trying to solve one of these, you're going to want to draw this picture that I just drew right here. Basically, a cross with a circle going through it, a little sniper scope. You'll see why here in a second. So we're looking at a negative arctangent, right? Well, again, I want to remind you in what quadrants is tangent negative, right? And tangent is analogous to slope, right? So a negative slope would pass through quadrants 2 and 4. So 2 and 4. Okay, so that means that's where my solutions are going to be, right? And I already know what my reference angle is going to be from this special trig ratio, but let's pretend that we didn't know. So you throw this into a calculator. The calculator is going to tell you that it's negative 30 degrees, right? And it's ridiculous to say, oh, well, the missing angle is negative 30 degrees. That's 100% ridiculous, okay? But we can use the magnitude of that angle as our reference angle, right? Meaning we can count up. So here's 180, here's 0, here's 360, right? We can count up in the quadrant 2 by how much? Well, duh, by 30 degrees. That means we would have to subtract from 180 30 degrees, right? So my first solution would be 150 degrees, right? And if we just follow this over, we would do likewise here. So I would use a reference angle again of minus 30 degrees from 360 so that I can come down into quadrant 4. And that would put me at 330 degrees. Okay, so there it is. Those would be my two solutions there. So I would say in this case, theta is equal to 150 degrees. That's my quadrant 2 solution. And it's also equal to 330 degrees. Okay, so let's look at some more examples. Let me erase and give myself some room. So looking at this, let's see which ones I really want to show you. Yeah, we'll go ahead and look at this one also. So 2 cosine theta equals the square root of 2. Again, my main objective in the beginning is to get the trig function by itself first. So I want to get cosine theta by itself first. I do that easily by just dividing by 2. We see that cosine theta equals the square root of 2 over 2. And there it is again. I see a nice, cute, special trig ratio that I should know. Um, Comes in handy when I go ahead and do the arc cosine of both sides, right? So I'm skipping a step here, right? Obviously, what I did was I did the arc cosine on the left, which canceled with this cosine here. And what I do to one side, I must do to the other. So that gets me to here. Okay, so throw this in a calculator. It's going to tell you 45 degrees. So let's draw our visual and see what that looks like. And it just bothers me when the circle comes out horrible. Screw it, that's good enough. Okay, so the calculator tells me 45 degrees, or you can look on your trig chart for special angles. It's going to be 45 degrees. And this is a positive arc cosine. This is the positive square root of 2 over 2, right? So that means we're going to be looking for our solutions in quadrants 1 and 4. Okay, cosine is analogous to x. X is positive in quadrants 1 and 4. Okay, so again, we have our little visual. Can't stress enough, this is geometry. It's super visual, and if you don't have that, it's going to make it a lot tougher. Okay, so our reference angle is 45 degrees. Well, duh, it's positive. That means our first solution, if our reference is 45, is going to be equal to a central angle of 45. So first solution is 45 degrees, just like I mentioned in the video before. When you have a reference angle in quadrant 1 or a central angle in quadrant 1, the two are going to be the same, right? Now we have to come down into quadrant 4. And to do that, we're going to have to say minus 45 to come down into quadrant 4. So 360 minus 45, well, that puts me at 315 degrees. So my two solutions here would be that theta is equal to 45 degrees. That's your quadrant 1 solution. And 315 degrees. Okay, and I neglected to mention the reason we're doing that is because we're saying that theta is anywhere from 0 all the way around to 360. Okay, and it turns out there's two angles that have this same arc sine. That's why these two angles are the solution to this trig equation. Okay, so not going to tarry too much longer. I'm probably just going to do, let's see here. I will do number 3 and number 4, just to keep this video short, because I wish this software would show me how long the video is going while I'm recording it, but it doesn't. It just surprises me at the end when I'm done. So I think I'm going to do this third example, and I'll do number 6 also, okay, because that was an example I wanted to show previously. So anyway, so number 3, again, first thing we want to do is get the trig function by itself, right? So we're going to have to undo this positive 1, this multiplication by negative 3. So starting from the outside in, I'm going to do subtraction by 1 first. So negative 3 sine theta is equal to negative 1, right? And, whoa, not negative 1, that's positive 1. What's the matter with me? Okay, then I'm going to divide by negative 3 on both sides because that's the inverse of multiplying by negative 3. So now I've got sine theta equals negative 1 over 3. Can't simplify that any further. Last thing, of course, we're going to do is the arc sine of both sides. What you do to one side, you do to the other. So that brings us to where we're going to get our answers from, the arc sine of negative 1/3. Now, 1 over 3 is not a special trig ratio, so I'm going to have to use my calculator here. Okay, so while my calculator software is booting up, I'll go ahead and try to draw this picture as well as I can. So we're looking for a negative arc sine, right? So where is sine negative? Well, of course, it's negative where y is negative, and that is going to be, I could have sworn I changed colors, and that is going to be in quadrants 3 and quadrants 4, okay? So in quadrant 3 and 4, because sine is analogous to y, and y, of course, is negative in those same two quadrants. So I'm going to bring my calculator over here, and of course, it's going to occupy the full screen. Okay, so here we go. So all I'm going to do is throw this in the calculator. So I'm going to say arc sine of -1/3. And again, always make sure over here you're in degrees mode. Okay. Oh, cool. It just ignored all of my input because I didn't hit menu first. Okay, so let's try that again. Arc sine of -1/3. Okay, so it tells us something ridiculous again. -19.47 degrees. Well, we know that's ridiculous because we don't have negative angles, right? But the magnitude of -19.47 uh, is just 19.47. That is going to be our reference angle. So that means to get my two solutions, right, my quadrant 3 and my quadrant 4 solutions, I'm going to have to come down from 180 and from 360 respectively. Um, First by adding 19.47 degrees to 180, right? That's going to give me my quadrant 3 solution, and I would have to subtract 19.47 degrees to come down this way into quadrant 4 to get my quadrant 4 solution. Right. And kids ask me all the time, every year, how do you know if you add or subtract? And I guess I'll go ahead and hit on this now. So our angles increase as we go this direction. And I'm having a brain fart. That would be counterclockwise, right? So when we go counterclockwise, we get larger. So that means to go from 180 counterclockwise to quadrant 3, that means we must get larger. Well, duh. How do we get larger? We add, right? On the flip side, to go from 360, which is right on the x-axis, down here into quadrant 4, we would have to go clockwise. So that means we have to get smaller. And how do we get smaller? Duh, we subtract. Okay, so that's how you know when to add or subtract. Okay, so anyway, went off on a tangent there. Yeah, see what I did? Tangent. Anyway, so I'm going to say 180 uh, minus, and then I'm going to just, oh crap. Then I'm just going to highlight this. You're probably wondering why I did minus. Well, this is a double negative. Okay, so just so I don't confuse anybody, fine. I'm just going to use positive. So I'm going to say plus 19 point blah, blah, blah. Okay, so that means this quadrant 3 solution is 199.47. 199.47 would be this guy here. Okay, and to get my quadrant 4, I'm going to do 360 minus, I'll just go ahead and change it. You guys that are real savvy with signs and everything, I'll share with you in class, but just for the sake of not messing anyone up, we're treating this as its only positive 19.47. Okay, so my quadrant 4 solution is going to be 340.53. 340, oops, 0.53. Putting the decimal in the wrong spot. Okay, so my two solutions here are approximately, because we're not exact, approximately 199.47. That would be my quadrant 3 solution. And 340.53. That would be my quadrant 4 solution. Okay, so one last example, because I'm pretty sure I've gone over 10 minutes by now. And we'll be done with this video. Um, and this is probably the most difficult example just because, well, we've got a square here. Okay, so I've got sine squared theta equals 3/4. Okay, and again, when you see this, it just means this. That whole thing is squared. Okay, but we need to get used to not seeing it that way. We'll see it like this: sine squared theta. Okay, so like previously, we got to get the trig function by itself. To do that, we have to do the inverse of the square, which is the square root. And when we do that, we'll end up with sine theta is equal to, now, this is where it gets tricky. We have to remember the duality of squares. Anytime that you take the square root of something, it's always positive or negative, right? So, for example, the square root of 16 is positive or negative 4. So that means the square root of 3/4 is plus or minus the square root of 3 over 4. Okay? And if we do the quotient law of radicals, that says the square root of x over y equals the square root of x over the square root of y individually, we see that we really have plus or minus the square root of 3 over 2. Okay? So now we do arc sine. So theta equals the arc sine of positive or negative square root of 3 over 2. Okay? So this is where the calculator is going to be useless to us except in just getting a reference angle. But this is a special trig ratio, so we don't even need the calculator. But if you throw it in the calculator, let's say you do the positive one first, because that's all you really need. If you do the arc sine of square root of 3 over 2, it's going to tell you 60 degrees, right? That's hang on to that. That's going to be our reference angle that we're going to use over and over again. So 0, 180, 360. So we need to ask ourselves, well, where are our solutions going to be? And the answer is in all four quadrants. Let's talk about why. Where is sine positive? Well, sine is positive in quadrants 1 and 2 because that's where y is positive, right? Where is sine negative? It would be negative rather in quadrants 3 and 4. So we're going to have four solutions, one from each quadrant. We know our reference angle is just 60 degrees. And just to prove a point, because you're probably not even listening to me, if I do arc sine of control x squared 3 over 2, okay, it's going to tell me 60. There it is. Okay, so I know one solution is in quadrant 1. Reference angle is 60. And my central angle in solution is therefore also 60. Okay, so for my quadrant 2 solution, I'm going to use that same reference angle, right? And we're going clockwise this time. So that means we're getting smaller. So we have to do minus 60, right? So that means that we're going to be here at 120. That would be my other quadrant 2 solution. Next solution is going to be down this way in quadrant 3 because now we need the negative solutions, right? So to go from 180 down into quadrant 3, I'm going counterclockwise. So that means I add 60 degrees. That's my reference angle. Either way, that's going to give me 240 degrees. Okay, and I'm going to come down into quadrant 4 from 360. And because that is clockwise, I'm going to subtract 60 degrees, giving me my fourth and final solution of 300 degrees. So my four answers would be 60 degrees, 120, 240, and 300. So basically what happened there is because I have this plus or minus, my answer ended up being every single angle that has a reference angle of 60 degrees, which again is 60, 120, 240, and 300. So those would be my four solutions there. Okay, so anytime you take a square root, remember the duality of squares. It's going to affect how many solutions that you get. Okay, so I'm going to stop now on this video that's going on way too long probably. Like always, if you have any questions over anything, send me an email. Otherwise, you know where to find me. Goodbye.